That's okay. Up until here, right? All of this we got from the original equation of motion. That's the one that they mean is the same. Which sort of makes sense because that's Newton's law of gravitation. So that's still operating. Okay. Now, this I want to change here. Okay, so my initial conditions are different. At time 0, I want to know where I am and where I'm heading. Okay. So, fired vertically upwards with speed v, capital V. Now, that's a bit confusing, isn't it? So, try to be careful. I'm going to put a little tail on my lowercase v so that you can try and distinguish, okay? So there's my tail, and there's my big V, which is the actual velocity I start at, okay? So, variable, constant. Variable, constant, okay? And where am I? Well, I'm not distance d. I'm fired from the surface of the Earth, right? And remember that x is the distance from the center. So how far is the surface from the center? Well, they actually tell you there, the radius of the Earth, right? Okay, great. So now, assuming the same equation of motion as in the previous question, I want to show that k has a particular value, right? So let's have a go at this, shall we? I'm going to use these conditions here. I'm going to say, I can bring in this x and this v together. I should put my tail there, right? Substitute in. So what do I get? Yeah, v squared is equal to 2k on r plus c. Okay. Now, what are you going to do with that? Any thoughts? Who's gotten this far? Who's gotten this far? Hands up. Yeah. What did you do at this point, Daniel? This is 25 part A. I'm trying to show that k equals a certain value. What did you do? Good. Now, okay. I'm going to get at this in a second. This is what I mean, right? You can't just blindly put in constants into your equations, right? Because as it turns out, when you look at this, you're trying to get a value for k, and they actually tell you what it is, what result you should get, right? But you're like, hold on a second. That value for k has nothing to do with this equation, right? The value for k is gr squared. So there's gravity's involved, and there's an r squared. Now, I don't have an r squared, and I don't have a force either. I've got velocity, right? So where does that fit in? Where should I go? I was going, where did I substitute? Here. This is what I substituted my initial conditions in, okay? And it didn't turn out to be very useful. So where did you put it, Daniel?
Sorry?
Where did you put it instead?
I let acceleration equal g.
Okay. Now, let's be a little more specific, right? They actually give us g as just a constant later on, right? Actually, did they say it's positive? Well, anyway. I'm going to give it as minus g, okay? Because I'm actually going toward the Earth. Does that make sense? So I want x to reduce. So I want it to be minus, okay? If it was positive, I'm heading away. But g is right, okay? So what am I going to do with this? Well, I want to come back to my original equation for acceleration, right? Does that make sense? So if this is the case, minus g equals minus k, pause. There's only one place where we actually get this force operating, right? Because this tells you the particular force at a particular place. When your place changes, the force changes as well, right? So where is the force G? Namely, well, it's at the surface of the Earth, right? So actually, if you went closer, you'd experience more, and if you went further away, you'd experience less, right? So here, I'm going to put in r to the minus 2. Does that make sense? Okay, now what did I want again? I wanted k. So let's simplify a little bit. I've got g equals k on r squared. Okay. So that gives you now, that's the, if you kick your r squared over the other side, there's the result they were after. Okay. Now, try not to be overwhelmed. More letters, but they're just constants, right? And you'll actually get some values for these constants in a second. All right, there's part A. Part B. Sorry, I should have said part A here, I guess. Now we're going to get to this v squared equation. Okay, I've got v squared being equal to 2k on r plus a constant. Okay, but I actually know what k is, right? It's 2gr squared. Yeah? And this v here, right? This lowercase v, actually it is an uppercase v. That's my initial velocity. That's how far I roll that. Okay? So now, when I want to work out my v squared, I stuck in initial conditions before I got a particular c. Since my initial conditions have changed, I'm going to get a different c, a different constant. Okay? In fact, I'm going to get this. Let's see. V squared. Capital V squared. Minus. That's just going to be 2gr. Okay? So bring that back to your equation. I wanted an equation for v squared. Right? So lowercase v, now this is actually my variable, right? Is equal to 2k on, sorry, that's gr squared, x plus capital V, that constant there, right? Minus 2gr. Right? Now I can tidy this up just a little bit. It's not a huge amount, but this 2gr and that 2gr squared, if I stick them together, I can do, how shall I do this? What's the best way? I'm going to go like this. 1 over x, 1 over r. Okay. Now, there's my initial, that's my anywhere velocity, okay, based on where I am. Now, before we move any further, let's just make sure that this works out, okay, does it make sense? Stick in your initial condition, namely that you're sitting on the surface of the planet, so your distance from the center is r, the radius. If I stick r into here, what happens? You stick r into here, you get 1 over r minus 1 over r. So this part here, this weird, complicated mess, will become 0. Yes? So that means my velocity at that particular time will equal my initial velocity. Check. Okay. What happens as x increases? As x gets bigger, how's this thing behaving? Any takers? Yeah, okay, so as x gets bigger, right, this thing is actually decreasing, right? So hold on, let's write it like this. As x approaches infinity, okay, as we get further and further away, right, 1 over x is approaching 0, yes? So that means 1 over x minus 1 over r is approaching what? It's just approaching that part, right? Because this initial part is disappearing, okay? So therefore, this whole thing, 2gr squared times that, what is that approaching? Now, what does that mean? What does that mean? What does that say about, as you go further away, what's happening to your initial velocity? It's getting slower, right? That's the effect that this has, okay? It's taking your initial velocity and reducing it by some amount. That's what the negative is, okay? Okay, now, here is our answer for B, okay? So far, so good. No, actually, that's the first part of B. The maximum height of the projectile. Maximum height of the projectile. Now, we talked about Pavlov's dog before, right? You could look at this and say, oh, differentiate that. What an awful mess. What could we do instead? Maximum height.